Let's talk about the basics of functions. So the idea is that a function defines a relationship between x and y. We input a value of x, and then following that relationship, we'll get some output for y. So we have our function notation here, y is equal to f of x, where we can see what our input is, and then how our function f is defined will tell us how we change that input to turn it into y. Let's look at a verbal representation. So if we had a word problem, how would we interpret function notation? So let's say we have b equals n of t, and this represents the number of birds b in thousands migrating through Washington t years after 1990. So what does it mean if we have n of 7 equals 9.2? So our input of 7 is t, and that's the years after 1990. So what that would tell me is 7 years after 1990, so that would be 1997. And then the 9.2 on the other side of the equation is what we're getting as our output from n of t, which we're saying is b, which is the number of birds in thousands. So we have 9.2 thousand birds. And then what we can do is put those together in a nice sentence. So we could say, in 1997, 9,200 birds migrated through Washington. Okay, let's take a look at function notation as it pertains to tables. So, determine if each of these tables represents a function. So what we're looking for is the fact that for every x value, for every input, there's exactly one output. So what it really comes down to is we should have unique inputs for our function. So what I'm going to do is just focus on x here. So I see a -1, 0, 1, 2, 3, 4. Those are all different from each other, so I'm liking that table. That table right there is a function. With the next one, what I have is 1, 4, -2, and then I'm seeing 1 again. And as soon as that x value of 1 repeats, I know that is not a function. As for every input, there should just be one output, and this is saying when our input is 1, it could have an output of 0 or 3. And that's not okay. So we know that second table is not a function. So what we're going to do is use this first table to answer some questions using function notation. So if I'm looking for f of 1, then what I would do is go and look for where is x equal to 1, and then I want the associated y value, which in this case is a +1. If I'm looking for f of 6, I would look for where x is 6 on the table. With this table, it's not on there, so what I would just say is does not exist, or we could use D and E for short. So that is for does not exist. If we want to solve f of x equals 1, so that's where we're given a y value, is what's coming out of that, and we're trying to find x. And what we want to be careful of is there could be more than one solution here. So I'm going to go x equals, and I could end up with a list of values, I could end up with nothing. I'm just going to go to the table and look for where does y equal 1, making sure I scan across the whole table, because there could be more than one case, which there is. So this happens when x is equal to -1, when x is equal to +1, and when x is equal to 3. So we end up with 3 possibilities. So I like this as a comparison of how functions work. When we look at f of 1, and even when we look at f of 6, there should only be one value coming out, because that's our plugging in our value for x. We should only have one output. However, the opposite isn't necessarily true. Our outputs can match up with several inputs. So when you're solving, you might get more than one solution out. Then with this last one where f of x is equal to 6, what we're going to do is look for where we have y equals 6 on our table, but what we'll see is it doesn't come up. And for this one, our answer changes a little bit because we're looking for a solution. We're trying to find all values of x where y is equal to 6. What we would write is no solution here. All right, so just a little introduction to functions there.